different types of protocols. So they have the older SOAP protocol, RESTful, which is more widely spread, GraphQL, and gRPC. And each one of these provides a unique set of benefits over others, but essentially is a tenet of communication through API. And I thought it was an alarm. And APIs just don't exist at only one level of the application. They transcend the entire hierarchy. So why would you not think about creating an API for yourself when you're working with a low-level API rather than when you're creating something maybe public or consumer-facing? We should pay the same level of attention and hold ourselves to the same level of disciplines. That's not relevant. So you might think of this as well as like a software development kit, which is a tool for third-party developers to kind of consume an API. And it's usually provided as a kind of like opinionated definition of how we imagine you were going to use this API and how we recommend using this API. So it's always really useful to kind of check out if there's an SDK available for an API to be using with, and it gets an idea of how your consumer is going to use it. But there is a bit of a divide between API-driven code that you might see in the wild and code we write every day. Maybe it's only on public code. Maybe it's only code that we don't have to document, or maybe code that we don't test. Spoiler, you should test. But it's easy to dismiss these sort of internal changes and sort of things that are a bit below the radar as not requiring the same level of attention, same level of due diligence when it comes to testing and attention. But why should we not hold ourselves to the same levels of standard? Why should we be letting our standards lapse here? So it's most evident when you're talking about tech debt, and this sort of starts to slide in and starts to kind of become a problem, especially when you're onboarding new colleagues and trying to onboard them into the new project. But it also kind of applies to yourself in 2 weeks. Like, I can't remember the code I wrote 2 weeks ago. It was probably terrible. And that's the important thing to remember, is you're doing yourself a favor. It's not just other people, but it does benefit other people, so it's great. So, of course, tech debt can increase the learning curve for new hires and new people joining the project. It takes longer to peer review because you're often having to explain all of extra things around what the purpose was behind this code. It's not self-documenting. And it's always unpleasant to resolve unless you're, of course, just deleting it, because that's fun. Increased risk of bugs if your code is kind of littered with tech debt. And ultimately slowed feature delivery. It always reminds me of this quote. So debugging is like being a detective where you're also the murderer, which I find to be also so true. So where do we get these sort of double standards? We have this idea of what code should look like in the wild, and if we're using it as a consumer-driven API, or if we've got code on the local side. So where does this kind of divide come from? Your code will always be consumed by other people. There's just no escaping it. This is the purpose for us writing code in the first place. There's going to be somebody else looking at it. So, think of them a little bit as well. And think about how, if you're making the job easier for somebody else, it's quite likely they'll do you the same favor in return. So tech debt is it's very rarely paid back, and it's difficult to manage. So it's good just not to introduce in the first place. And having respect for your colleagues, making their lives a bit easier. And one final thing is that test code could be considered production code that's just not shipped. And I really like this idea because it teaches you to have the same principles, the same level of self-discipline when you're writing test code, when there may be few people that will actually see this. Which also then reminds me about this one. This is always code as if the person ending up maintaining your code is a violent psychopath that has your address. Good one to remember. So let's just say, hypothetically, we all want to be good citizens. We start up waking up in the morning and we think, today's going to be a good day. I'm going to really put the effort in. How do we identify what good code looks like? So I've mentioned all the difficulties and problems with APIs and how they might look like and what we should do. But what does good code look like? Well, it turns out it's not so easy to answer that question, because there's no such thing as perfect code. It doesn't really exist. You might be aware of the Nirvana fallacy or the perfect solution fallacy, where perfect is the enemy of good. That's become a bit of a cliche, but it's still true. As I mentioned, the perfect solution fallacy called Nirvana fallacy. And it becomes a real problem for API maintainers because, you have to make a decision about what the API is going to look like. And if you're sort of shackling yourself to this implementation, then you're going to have to maintain it and look after it for as long as you have consumers, which can, if you are unfortunate to have a successful product, be many. So the focusing thing is to just focus on done, get it finished, and then work on make it better. So iteration through slow improvement. A wise French writer once said that a wise Italian once said that the best was the enemy of good. That's how the Nirvana fallacy kind of phrase sort of came to be. Yeah, it's just a bit of an alliteration. So code progressively through abstraction. Think of the smallest API service that you can get away for this feature, and focus on that, and then slowly improve upon that and then increase as you get to know your understanding. As you get to know and increasingly learn your requirements and the requirements of your users, which include you. So keep your API service as small as possible. Allow yourself room to change. So try not to expose behavior and keep your contract simple, which means you have a bit more flexibility about the internal implementation, so you can change it a little bit without having breaking changes or API changes. I would always say try and prefer interfaces, but also consider the Yagni phrase, which is you ain't going to need it. If you're creating an interface for every one implementation, maybe you only need one implementation. But there are definitely benefits to using interface in Kotlin, such as interface delegation, implementation behaviors, and such. Always prefer composition over inheritance and interface segregation. So you want to make sure that your interface contracts are quite small and purpose-built. So you've not got every function that you might need in there, just the ones that you need for that single purpose. And that allows you to sort of kind of break off or branch parts of your API if you need to. So it's all about kind of giving yourself flexibility and room to breathe in a situation where, well, I made a mistake, or the API wasn't perfect, or there could be improvements to make. It's giving yourself that flexibility. Some might argue about usefulness of documentation. I'm personally not a fan of documentation. I think it's mostly redundant, and if you really do need to document your code, either the code is too ambiguous and unclear what it's doing, or you didn't write any unit tests. But there are some rare cases where JavaDoc can be where it's maintained effectively can be useful, especially in public-facing documentation. But code should be always, should aim to be self-documenting and self-clear about what it's doing. And name considerably and with purpose. Really take time to think about if you're naming something as simple as a simple variable. Like, think about what its purpose is, what its reason for existing. Maybe a bit too far existential, but you get the idea. And then there's another thing to consider is that considering sources of code smell. Now this is like a litmus test that a lot of people try and do, but you can be pretty extreme in how you view what a code smell might look like. Code smell might just be, having too many indentations, but it could also be having any indentations. So conditional statements can often be the kind of a source of code smell, because if they're not written properly, then they're logically dividing the sequence of operations. Iteration recursion can be kind of a sign of code smell, and these tools are all fine to be used individually and when they make sense, but overuse can cause issues. Polymorphism, just stay away from it. It's just where you've got code that sort of behaves differently with the same inputs, or just is unpredictable. And mutability, it's one of our sins in Kotlin. And significant indentation. You might have seen this Hadouken meme, which I always find quite funny. This is JavaScript callback hell. It's always great. So coming back to it, so there's only two hard things in computer science: cache invalidation, naming things, and off by one errors. So meaningful namings is quite important. So consider this code block. It's obviously contrived, but what's going on here? You can't really see at all what it is I'm operating on. Okay, so I is probably an index over a key set, and that C is connecting to something. Like, it's very unclear what's going on. And not only that, is you're suppressing an exception here, which is just not a good idea. But even if you do suppress the exception and you're not going to handle it, then being clear about what you're doing, so naming it ignored and giving some justification for why you're doing that. Just simple things like little naming of your variables can have a big impact on how your code is understood. And one thing I always like to kind of emphasize as well is the strength of the signature methods that you have available to you. So you don't just have this one word in the middle where you can name your function. You've got the whole thing, which is giving you information. So you've got publicity, the public explicitly mentioned here. You can see that it's suspended, so it's asynchronous. Infants function using Kotlin notation for getting rid of dot notation. And then you have the receiver and the actual name. So these each one of these things provides essential information about what your function is doing. And it means you don't have to have a really long, overly verbose function saying drops this from there when this condition might be true. It's ludicrous. Yeah, so some examples of this from one of my previous projects sort of already kind of show a bit of code smell here. So, for example, you've got there's got functions that form multiple behaviors and conditionally. So it's quite clear that in the first one that I'm updating a claim with policy details because I'm passing you both the claim and the policy details. It's going to be a bit obviously doing something with that. But then you've got conditional operators in the names of the functions as well. So you can see that it's polymorphic, doing more than one thing. So, should this be, could this be changed or kind of destructured in such a way that it's a bit more explicit? And the is null or empty and compare and set are a bit more ubiquitous in the Java world as they're provided by framework implementations. But you get the idea of this usefulness of, or usefulness of command words in your method. Don't be lazy with interface implementations. I've seen this quite often where you've only got one implementation for an interface, and you'll just name it impl because I'm too busy to think of naming. I mean, first off, it sort of implies that you might not actually need this interface in the first place because you've only got one implementation. But let's say, for example, you want to provide some test cases and some test implementations, which would then be another production version. It gives them context about what is special about this class. So, for example, this view state might be provided by the Android view model provider, or it might be some cross-platform approach or something. There might be something different about this implementation that sets it apart from the interface. Otherwise, why have the interface? Another red flag, big no-no, is impure functions. This is functions that hold state, so that the results is actually different depending on how many times you might invoke that function. And since we're getting more familiar with the compose world now, at least we're getting more familiar with the idea and concept of this immutable kind of replay behavior. Always having a reproducible state, having modifications where it makes sense, and don't expose mutable state. Just don't do it. Also, interface composition, so always prefer interfaces over inheritance, which is really useful in Kotlin, since we can provide implementations with interface delegation, and it provides a lot of restrictions coming down to the consumer on what class they can use. For example, if you're extending from an abstract class, then you can only extend for one, and it locks you down to a little bit. And what if the client wants to change to a different library or change to a different implementation? It's generally not very scalable to use this approach. One example I quite like of this, of actually using interfaces effectively, is actually using what's called factory functions. You might have seen this in the coroutines code base, where you've got a top-level function with the same name as the class that it instantiates. These are called factory functions. And they could be thought to violate the naming convention of having a lowercase letter, but because you're actually creating an instance of the named class, it's an allowable construct. And it's quite nice because you're only defining the interface, and then you've got a function that immediately returns that interface. So no this impl behavior going on. This is in the coroutine code base, you can check out. Another really useful tool is being able to democratize your API decisions. So kind of involve everyone in your team, because everyone's going to be using this technology. Everyone's going to be using your code that you may be written. So it's going to be useful to get the input and opinion of those in your team. So by democratizing that API decisions, you can maybe create a council, maybe a small group of people to decide if an API decision is worthwhile or not. But of course, doing that too much, you can end up in bureaucracy hell. And coming from Germany, I can say that's not fun. But it does allow you to have a bit of peer review scrutiny, and there are a lot of benefits from it. There's also some nice sort of co-working techniques you can use. One's called mob programming, which is a type of pair programming where you sort of have one driving person and everyone else is just yelling at that person what to do. Now, of course, this is not productive. doesn't really get a difficult problem solved, but it is actually a nice effort in team working and getting people to communicate better in a team. So these ideas kind of can really help in small teams as well. And there's the example of the Android API Council, a bit on a large scale, but yeah. And guild meetings. So, of course, I wouldn't be covering this topic properly if I didn't mention the elephant in the room, the white Gradle elephant, of how modularization can affect this. So simply by making better API decisions, you can make it much easier for yourself to modularize your features into smaller, really tightly knit implementations. And the benefit that this has is it means that Gradle can then do a lot more advanced caching on your build, so you actually benefit significantly from having reduced build times. And compound that with Gradle Enterprise, then you've got all these cached artifacts that you can use. So it's generally a good thing, and let's go into why. So if you're not familiar with modularization, it's this process of taking code from what might be like in a monolithic single module application and splitting it up into smaller parts, which are more feature-driven, maybe a bit more closed off with implementations so that it's more kind of secretive, so that you can make changes in isolation. And being able to make changes in isolation is a really powerful ability, because you're not having to test the entire project, just this little bit that you've changed. And it gives you that freedom and flexibility that I mentioned earlier. And it's quite funny as well, actually. You might hear from some people how many modules they have. I've heard people boasting that they have hundreds of modules in their project. I think even one said thousands. So I keep on pressing this when I shouldn't. But yeah, combined with code secrecy and keeping implementations internal, this can be a really cool and key role in effective API design. So as mentioned, it means because then you can build these things concurrently. You can actually have modules building in unison at the same time, because they don't have a clear dependency, or dependency has been moved somewhere else, and then you've got effective modularization, means you can cache your artifacts properly, and you gain a lot of time here. Like, I cannot underestimate how much time that I thought we would actually get, and how much time we actually got in return for this. So from starting using caching, it was like down from 20 minutes clean build to in good circumstances. But yeah, this idea of using effective modularization for good artifact caching is really powerful. Yeah, so we'll also combine this with Gradle Enterprise, not sponsored by Gradle here, so I'm going to try and keep this a little bit quicker than I thought. But yeah, I can really recommend using Gradle Scan to kind of identify the bottlenecks in your build. You can see where there's any kind of issues, where there's like ineffective cache going on, or it didn't invalidate the cache properly, or something that is happening that shouldn't be. You can use its Gradle Scan for free. Enterprise is on a custom tier thing, so you have to contact them, but you can still use some of the features in their Gradle artifact caching factory. So it's important to remember as well that not everything here is a silver bullet, and modularizing can actually hurt you if you are not too careful. So things like misaligned product flavors, misbehaving dependencies, the very things that I mentioned that you can use a Gradle Scan to find, but they can actually give you a net negative result in your build, because it's doing something unnecessarily, or some work has been repeated when it doesn't need to be. So keep on the ball with this, keep on track with your Gradle scans, and you should be able to find out where there are any issues having. But fundamentally, I think it's really important to remember that we're all human, and the whole point of this idea about encapsulating code and keeping implementations private is sort of to give yourself that flexibility and to sort of hide any potential mistakes that will eventually and inevitably happen, because we're human, we make mistakes, and the only thing you can do is make it as easy as possible to recover from your fuck up. So always be aware that there is going to be a potential for risk. You cannot avoid it. It's just risk management. You can really make use of annotations to your advantage. So you might be familiar with the deprecated annotation and the requires in annotation, but the deprecated annotation is super useful when you're managing an API for other people, because you can actually give instructions on how to migrate to the new intended practice. And then a lot of times you can actually use the auto command in IntelliJ to actually replace everything in your project, which is very cool. And you can distinguish whether it should be, failing the build or just giving the user a bit of a warning. So it gives you a lot of options to give information and communicate this better without having to rely upon documentation that's probably going to get outdated. You've also got the requires opt-in. Now, it's very similar to deprecated, but allows you to convey a little bit more information about where it's supposed to be used, since you're actually defining your own annotation to do it. So then you have to specify what targets this is going to have, where it is appropriate. You will see this in examples with things like the experimental coroutines API or the experimental compose API, but you can create your own. In a previous project, I created this technical debt and visible for modularization, which sort of were a bit more of a kind of concrete way of declaring, like, yeah, I know this part of the code is a bit sucky, and we've created a Jira ticket so it's being tracked. It's not just a code with to-do saying, I'll do this on Friday. You're actually, putting it to an issue tracking system so that you're contributing and committing to doing that a bit later. Whether that works is yet to be told, but it certainly is improvement on the to-do. Yeah, an example of this in play with the deprecated annotation on the RX libraries for coroutines. This is where it's creating a coroutine completable from, an RX Java completable from a coroutine scope. But you can see how it's deprecated. It's giving useful information, an actual error level so that it won't actually compile, and a very clear and effective replace with annotation saying, this is how to move on from this. It allows the user, the developer to move very quickly. But a problem that I found with this is that if you're in a position where your decision can come back to haunt you, and that there's a possibility of risk, and that you probably are going to cock it up, you don't want to make a decision, so that leads to decision paralysis. The irony of this being, decision paralysis is the worst decision you can possibly make. So I'd like to sort of conclude it in a way that it's more about risk management and giving yourself flexibility. Because good code might not be code that documents itself, or code that can be changed easily or readily maintainable, follows all design principles. No, I think ultimately good code is code that is most easily deleted. There's a great quote that was a bit more generic, and given it's quite dated, but it was adapted to computer science. And that is, everything existing that is born without reason prolongs itself out of weakness and dies by chance. Adapted for computer science, that is, every line of code is written without reason, maintained out of weakness, and deleted only by chance. Yeah, so some further reading. I'll share the links for this later, and the slides themselves. If you're interested. Yeah. Thanks, everyone.